we're going to go through an example where we home a motor. And this example, I happen to be using an ACE 11, but you could use any of our PLCs. ACE 11, you just know if it works on this, it'll work on any of them. It's in the setup hardware. You can see that I've defined our output pins for the step and direction. You want to be sure to do that. And then I'm creating this as a subroutine, and you could easily pull this subroutine into your own project. In this, as you see, our main routine, all it's doing is it's looping around. In practice, you'd call this probably in your main loop, and then you would check to see if it's completed its homing task, and I'll show you how you'll know that in a minute. And then below that in your main loop, you'd probably have your other states that would perform the real task. Maybe you're going back and forth with the motor or something like that. So let's start looking at the subroutine we created. It's got 4 parameters that are passed into it. There's the state home, so this whole thing's going to be a state machine, and it's going to allow our main program to know what state we're in regarding homing. There's the home limit, so this is the actual input bit for probably a switch, a limit switch. That'll let us know if we've reached our home. We've got our location, so we're going to relay to the main program where we are in space. And then we also have a bit we pass in that tells the subroutine if the home is in the negative direction or is it in the positive direction. And based on that, it'll tell it to go a different way. So the program, it starts out by asking, hey, is it negative or is it positive? And if so, we create 2 essentially destinations we're going to go to. We've got one that I've typed in 100 million as steps. And if you're going the other direction, we'll go negative 100 million. And the idea here is, in a moment, we're going to send the motor really, really far away. The idea is it's farther than we're going to want to really go. That lets us know that we will hit the limit switch before we ever reach the destination we're going to set. And then there's another smaller destination. I'm using 300 or negative 300 here. And I'll talk about that in a minute. So the first time it comes through, the state home is going to be equal to 0. That's because we haven't initialized it to anything else. So just like any integer, it'll start with the value 0. The next thing we do is we issue a motion output command. And you can see that we give it the location. We give it a tag to store its location in. We tell it to go to the location 2, and you see that's the really big number here, whether it's in the positive or the negative direction. It's just tell it to go farther than we need it to go is the idea. We establish a speed, a soft start and stop time. That's because when you're working with stepper motors, you typically don't want them to abruptly stop. You want to give them a little slow down time. The next thing, we define the input, the digital input for our limit switch. So we're tying that to that home limit, the one that we passed in right here. And you see it's passed in by reference. So whenever it happens, it's directly tied to that data. It'll know exactly when it happened. And then we tell it to store the location that was seen once that home limit occurred. We want to know exactly where in space we were when that happened. And then we also have a bit, we're calling it home found, that when it rises, we know that this motion block has captured the home limit rising, and we can use that to know if we can go to the next step in our operation. So we have this motion out command, and then we advance the state as we commonly do. And we're going ahead, and right here I'm clearing out the location. The idea is maybe we've done this homing another time, or we could be, I don't know, anywhere in space. So I'm just going to go ahead and zero it out. I don't even know if that's all that critical, the zeroing out, because of what we're going to do in a minute here. I think the idea is we could be real far in space, and we just want to have a basic starting point. Anyways, you see that this just leads to a return block. So the next time it's going to go through here, it'll loop back on itself in this case. It'll say is state equal 1. It will be. and it'll ask if the home is found. And it'll just keep hammering that until it finally has been found. At which point we're going to do a real quick math operation here. We're going to take the location it's currently at, and we're going to subtract out the location that the home was found at. So that will effectively make the place where it saw that limit switch, it's going to make that location 0. And wherever we are in space from then on, we've established where 0 is. And we know exactly where the home is, and we can reference any movement from that. So we've zeroed that out, and the next thing we're going to do is we're going to tell it to go to some. We're going to tell it to go a little further in the same direction. That's where this slow move comes in. It's another location. It's the destination. In our case, I'm saying 300 steps in the same direction we've been going. Go 300 more steps, and the idea there is I know that that's enough steps that it can perform its slowdown in. So you still, just because you hit a home switch doesn't mean you necessarily want it to abruptly stop. You can give it a little bit of time to complete its movement, and that's what we're doing there. And then we advance the state to state equals 2. And the idea there is just we want it in a state that our main routine, it could look for and say, hey, is that state home? Is it equal to 2? That tells us if it is, then we know we've completed our homing sequence and we can move on to the next task, maybe the real task. So we can watch this in practice. I'm going to program this. I have a PLC plugged in, and you can see in this case I'm saying yes, the home is in the negative direction. That's the key thing here. I put a 1 into it when I set it up. So you'll see if we look at the values here, you see it's moving in that negative direction. It'll keep moving right until I push the switch, at which point it zeroed. It was a little hard to see because it happens quickly. It zeroed out the location by using this math block here, and then it continued moving 300 more steps, just like we told it to. And at that point, the motor stopped. It slowed down during that 300 steps, and slowed down to a stop, and advanced the state equals 2. So state is equal to 2 now. And in our main routine, we can see the state is equal to 2. We know where we're at in space, and now we can move on with our main state machine. So yeah, that's the basic idea how you do some homing.